Good morning, all. Today we have to discuss inverse circular functions. Inverse circular functions. Circular function is nothing but sine z cos z. I intentionally write this z here instead of x and y because we are considering this function as a function of complex numbers. So circular functions of complex numbers. First, we consider two real numbers, alpha and beta. When alpha and beta are reals, we can consider the function cos beta as a real function and consider the equation alpha equal to cos beta. Then we know that from this you will write this is if and only if beta is equal to cos inverse of alpha. This is the meaning of inverse circular function. This is, in fact, it is a real circular function. Whenever we consider the circular functions, uh, this is what we mean by inverse circular functions or inverse trigonometric functions. From this, if alpha and beta are real, we know that this cos inverse can be considered as a function from. We know that cos beta assumes values only real numbers in between -1 and 1. So the domain of this cos inverse will be -1 to 1 to 0 pi. Okay. So if alpha and beta are real, so this is the domain and codomain of or range of this cos inverse. But if we consider cos z and sin z, we can say that these two functions are not bounded. So the domain will be the whole complex numbers. So we will consider what is the range or how to get the value of cos inverse of z. For that, we assume the complex number. Let x plus iv be the complex number. Also of u plus iv. What is the translation of this? This means cos inverse of x plus iy, that is equal to u plus iv. This is the meaning of the statement. We need to find cos inverse of xy. The one value is nothing but u plus iv here. From the equation itself, you will get this translation. And you can consider, we know that cos minus theta is same as cos theta. Okay, since cos is an even function. Therefore, we can write this cos minus theta plus 0 is same as cos theta. So this implies cos of minus theta plus 2n pi equal to cos theta. Okay, this is because the period of or the 0 can be replaced by any multiple of 2 pi. So you can write it as cos of minus theta plus 2n pi equal to cos theta. So if you put this equation here, you'll get x plus iy can be written as cos of 2n pi plus or minus u plus iv. Okay. Yeah, you know that cos minus theta is same as cos theta, therefore cos minus theta or plus theta both are same. So both will give cos theta here. So this can be written as cos of minus plus or minus theta plus 2n pi, that is same as cos theta. Then if you replace this theta by this u plus iv, you can write this x plus iv is equal to this one because this quantity is exactly same as cos of u plus iv. Okay, from this you can write, so this is same as cos of u plus iv cos inverse of x plus iy equal to 2 and pi plus or minus u plus iv. U plus iv. So this shows that this cos inverse x plus iy is not a single valued function. Okay, so if you fix an x plus iy, you will get many more values for this cos inverse. Okay, so if you fix one, say principal value, so we write it as cos inverse of x plus iy. C would be uh, capital. Okay, this denotes the principal value of cosinus. Okay, that is uh, that cos inverse of x plus iy is 2n pi plus or minus u plus iv. So the principal value is defined as the principal value of cos inverse is defined as cos inverse of x plus iy equal to one of the value of this 2n pi plus u plus or minus u plus iv, where this 2n pi plus or minus u belongs to, since this u plus iv is a complex number, u is a real number, so 2n plus un 2n pi plus or minus u is always a real number, so one of them should be in pi. So if this is the case, we will write this is the principal value of cosinverse. Okay, so this is the definition of cosinverse. Similarly, you can define sine inverse. Sine inverse of x plus iy. For this we use x plus iy, I put this is equal to u plus iv. Then you have x plus iy equal to sine u plus iv. But this quantity is same as sine n pi plus minus 1 power n u plus iv. Uh, this is because in the second and first quadrant the sign is always positive. Okay, so you can write it as sine n pi plus or minus n u plus iv. This shows that if n is equal to 1, then this will be pi, so this takes pi minus something. Pi minus something is always a positive quantity, that is sine of this the same u plus iv. If n is even, if n is 2, so this will be 2 pi plus this 2 pi plus this is in the first quadrant, so we can write it as sine of u plus iv. So both are same. So from this you can write sine inverse of x plus iy is equal to n pi plus minus 1 power n u plus iv. Okay, so the principal value of we know that if x is alpha and beta are real, if alpha and beta are are real, this alpha equal to sine beta defines the inverse function, right? As beta is equal to sine inverse alpha, and this is a function from again minus 1 1 to, here we have minus pi by 2 to pi by 2. In order to get this as a function, we need to collect a unique angle as sine inverse alpha. So that comes from this. In order to get the uniqueness, we will set the codomain as minus pi by 2 to pi by 2. So the principal value of this function, this sine inverse, is defined as sine inverse x plus iy equal to n pi plus minus 1 raised to n u plus minus 1 raised to nv times I. So this is the real part. If this real part belongs to minus pi by 2 to pi by 2, then we can say that this is the principal value of sine. Similarly, you can define tan. Tan inverse. Tan inverse is again tan inverse of x plus iy is equal to n pi plus tan inverse x plus iy. Or this is same as n pi plus this u plus iv. If you write x plus iy is equal to tan of u plus iv. So this was the tan inverse of this is equal to this. If this is the real part, if this real part comes from minus pi by 2 to pi by 2, again you can say that this is minus pi by 2 to pi by 2. This is the real part. If this real part comes from this, you can say that this is the principal value. So these are the principal values of, or we can consider these inverse circular functions are single valued functions other than the multi-valued functions. So using these values, you can define sec inverse, cosec inverse, cot inverse, etc. Using the property of those functions in the concerned quadrants. So here we know that in the third quadrant and first quadrant we have tan is positive. That's why this n pi is that is the role of n pi here. Now we can consider inverse hyperbolic functions. That is, if x equal to cos hy, then inverse hyperbolic function is written as cos h inverse of x equal to y. So this can be written as x equal to, what is cos hy? By definition, this is e raised to y plus e raised to minus y divided by 2. So you can make a equation from this using cross multiplication. We'll write it as 2x equal to e raised to y plus 1 by e power y. Here this symbolize 2x equal to e power 2y plus 1 whole divided by e power y. That implies e power 2y minus 2x e power y plus 1 equal to 0. If you put t is equal to e power y, put t is equal to e raised to y implies this is t square minus 2xt plus 1 equal to 0. Now it is a quadratic equation in t. So you can solve this equation for t, that is equal to minus b. Minus b is minus of minus 2x plus or minus square root of b square. B square is minus 2x whole square, that is 4x square, minus b square minus 4ac. 4 times a is 1 and c is 1, so this is 4 here, all divided by 2 times a, that is 2. So this implies t equal to, this will be 2x plus or minus. You can take 4 out from the root, that will be 2. So this is x square minus 1 all divided by 2, that is equal to x plus or minus square root of x square minus 1. In fact, this is e raised to y, that is equal to x plus or minus root of x square minus 1. So this implies, how do you get this y here? Y equal to log of, by taking log on both sides, x plus or minus square root of x square minus 1. Okay, so this implies cos h inverse of x equal to log of x plus or minus root of x square minus 1. So this is the expression for inverse hyperbolic functions. Now you have problems, separate into real and imaginary parts. Real and imaginary parts. The quantity sine inverse cos theta plus I sine theta, where theta is real. For this we write sine inverse of this quantity is equal to some x plus iy. Sine inverse of the same quantity cos theta plus I sine theta equal to x plus iy implies cos theta plus I sine theta equal to sine x plus iy. But we know that sine x plus iy can be written as sine x cos iy plus cos x sin iy. So this is equal to sin x cos iy plus cos x sin iy. The sin iy can be written as I times sin hy, and this cos iy is same as cos hy. So you have cos theta plus I sin theta equal to sin x cos hy plus I times cos x sin hy. So now we can compare these two. Cos theta is equal to sin x cos hy and sin theta is equal to this. This you can write cos theta equal to sin x cos hy and sin theta is equal to cos x sin hy. These two equations together imply that by squaring and adding we can get the left side as 1, and this will be sin square x cos h square y plus square of this. So that will be sin square x cos h square y plus cos square x sin h square y. So we can write here this cos h square y is 1 plus sin h square y. So this implies 1 equal to sin square x into 1 plus sin h square y plus cos square x sin h square y. So this is equal to now you can write this as by opening the bracket you can get sin square x. The second time will be sin square into sin h square. Here we have cos square x into sin h square. From this you can take sin h square out. So the remaining will be sin square x plus cos square x. So that will be 1. So this can be written as sin square x plus sin h square y. This implies you can write this is 1 minus sin square x equal to sin h square y. So this is cos square x equal to sin h square y. So this is the equation obtained from these two equations. Then we consider this equation again. This equation again we can get by squaring we can write this is sin square theta is equal to cos square x sin h square y. But we know that cos square is same as sin h square, so this will be cos raised to 4x. By assuming sin theta is positive, we can write it as sin theta is equal to cos square x. Okay, so this implies cos x equal to square root of sin theta, and hence x equal to cos inverse of root of sin theta. So now you got x. Okay, we need to find out this x plus iy in order to separate the real and imaginary parts. So for the first step we have seen what is this x. X is nothing but cos inverse of root of sin theta. Okay, now our next intention is to find what is y. In order to find y, we consider cos x equal to square root of minus square root of sin theta, and we write sin hy is equal to root of sin theta, because we know that cos square x is same as sin square y. So this implies e raised to y minus e raised to minus y divided by 2 equal to root of sin theta. Sin theta here. So this is again you can resolve this equation as a quadratic equation. So that will give e raised to 2y minus 2 root sin theta e raised to y minus 1 equal to 0. From this you can write what is e raised to y. E raised to y is minus b is this one, 2 root sin theta plus or minus root of b square is 4 sin theta minus 4ac, that is a is 1 and c is minus 1, so this is 4ac divided by 2. So this is equal to, you can take this 4 out and cancel with this 2, so that will be root sin theta plus or minus root of 1 plus 2, sorry, 2 is not here, 1 plus sine theta. This is the value of e raised to y. So you can get y is equal to log of this. Log of root of sine theta plus or minus 1 plus sine theta. We already know that what is x. X equal to cos inverse of root of sine theta. These all are with some assumption that sine theta is positive, cos theta is positive, sin hy is positive, and etc. So uh, you must assume that these things are true. Then you can solve or separate real and imaginary parts in this manner. There are similar problems in the textbook. Everything is worked out there. So you need to go through it, and if you have any doubts, please come to me. We can discuss through a Google Meet. Thank you.